So in this lesson, you're asked to find some data, a subset of some data. Okay. So in the case that you have in your homework, it's some random numbers, and you got to find the ones above a certain value or below a certain value or whatever it is. So, but I want to just make sure that everybody understands the details of how this works. So here I have a program that the first thing I do, of course, is I do clear the screen, the command window, clear all the variables out. You see the variables are cleared here, and close all of the graphs. So that's always a good way to start every script. First, I'm going to just generate some numbers. Now, these numbers aren't random, but they are what they are. So it's minus 10 to plus 10 by threes, right? So the first thing I can do is I can use logical indexing to find the variables that are greater than minus 6. So this could be greater than minus 6. Minus 6 will be here. And less than 6. Okay, so it's going to be these variables, minus 4, minus 1, 2, and 5. So logical indexing is done this way. I create a logical variable. Okay, so you can see that the logical variables, the one that fit in this interval, are minus 4, 1, 2, and 5, just like we thought. And then, if I want to extract those out of A, I can say B is equal to A sub findex. At this, and so if I do that, then here I get the values. So that is logical indexing, and it's very powerful because not only can you use it over here on the right-hand side of the equation, you can also use it on the left-hand side of the equation. We'll look at that as well. You don't need that for your lesson, but still, it's always good to know a little something about what's going on. Now, why do we call it logical indexing? Well, you see this guy Findex, he is indeed logical, and there in the workspace you can see that Findex is a 1 by 7 logical. And you can also see that A is has 7 elements, and Findex has 7 elements. You see, so I have a 0 or a 1 depending on whether or not they meet the condition. And then when I do the extraction, it just gets the ones where Findex is 1. So I don't get anything here. I don't get anything here. I get this one, minus 4. I get this one, minus 1. I get this one, 2. And I get this one, 5. And I don't get the 0. Okay. Now, there is another way to do this. You could do the same thing with find. And but find is a little different, and we'll see why. If you look here, you see that find returned a integer list of the indices. So here is the original A variable. So 0 or 1, 2, 3, 4, 5, and 6. So that's the indices of the variables that meet the condition. Now, let's take a look and see how you can use logical indexing on the left-hand side of the equal sign. And like I say, this is a little more than you really need to know, but let's take a look at this. So first, I create D, which is just nan, not a number, times A, and here's the values. So A was 7 by 1 and had these variables in it, but D is just going to be 7 by 1, but it's going to be nans. So and just as a reminder, here's what Findex is. Okay. And so what I'm going to do is I'm going to take, for all the true values, I'm going to take those variables out of A that meet the condition Findex, and I'll put them into the variable D in the position of Findex. So let's see what that looks like. And so there you can see I took the values minus 4, 1, 2, and 5 out of A, and put them in D in the correct position. So now let's do the same thing with the find. So the first thing I'm going to do is I'm going to create E, which is not a number. I already have index 3, 4, 5, and 6, and so but you can see that index is only 4 variables long. It's a 1 by 4, as opposed to Findex, which was a 1 by 7. But still, I can take those values, a sub 3, a sub 4, a sub 5, a sub 6, and I can put them in d sub 3, 4, 5, and 6. And there's d. And so you can see that I did indeed put d. I should have made that an e. Let me change that to an e, and we'll run him again. Okay, so now I'm going to take e, set that to nan, and then I'm going to transfer the values that are in the index position 3, 4, 5, and 6. So there's 1, 2, 3, 4, 5, and 6, and 8 wasn't in that list. So that's how logical indexing works, and that's also how the find function works.